Welcome. My name is Rick Garfunkel. I'm Vice President of Global Affairs. For those of you that don't know, I come from the sciences, and for the past 4 years I've had the honor and privilege of leading this unit of Rutgers called Rutgers Global, and for the old timers used to be called Gaia. Rutgers Global is the central unit of the university that helps support the approximately 10,000 international students and scholars who were at Rutgers. We lead the university's study abroad efforts. We support international and global events on campus, such as this, and usually they're coordinated by faculty, not so much by our staff. We help fund new initiatives on campus, and I'll talk a little bit more about that at lunch. We oversee hundreds of partnerships and MOUs with partners, institutions, and universities around the world. We host a range of short-term student, faculty, and administrative kind of programs on campus where we teach people here, etc. Rutgers Global has been supported for the past 6 or 8 years, since before my time, by an international advisory committee, and mostly faculty and a few administrators on that committee. Quite a few of you in the room are from that group. We decided to shake things up a little bit this year and try some different things. So instead of just us reporting out and having small report outs from some of you, open it up to a wider audience rather than just the IAC, and spend more time in hearing from you about your global initiatives. So the first event was a town hall held about 6 or 7 weeks ago, led by Rick Lee, and that had 9 speakers clustered into 3 groups. One speaking about undergraduate curricular education, a second about graduate resources and challenges, and a third group was talking about 3 specific individual initiatives, the Greek initiative, etc., the Thessaloniki of SEBS. Most of the participants seemed to find that first event quite engaging and informative. Today's event is more focused. Anu Gupta, here she is right here, who has lots of energy and herself contributes to global warming, her own energy level, asked to lead one of the events. We discussed about a dozen or so and eventually converged on a critically important one at the time, climate and sustainability, class of problems. So Anna put together this rather august pair of panels that we have this morning. The format of today's discussion is rather ultra short presentations, more or less introductory comments, followed by a longer period of discussion with question and answers. Most of the people you will hear from today have no problem giving you an hour or 2 lecture on their specific subject. They're limited to a few minutes first, and then a discussion so that we can sort of get a big picture understanding. They all have research, education, and service. In addition, quite a few of them are involved in policy making themselves. What else? Outcomes. New ideas, hopefully, for some of you who and your own research work, where you can, who you could partner with, where you might be able to have more global impact in your work, who you might partner with, for example, on your next research proposal, new courses for students, new study abroad or service learning programs that you might think about. That's enough on that. In addition to thanking Anu, I would like big thanks to Marty Kaplan, who agreed to moderate this morning, and Catherine Roscoe, Rick Lee, Karen Fowler, Christina Miles, and a few others from Rutgers Global for helping on PR, logistics, etc. So I personally envision Rutgers and encourage that we become more of a global university, not just the State University of New Jersey. This is what I get paid to do. And I would very much like to see that Rutgers have more impact on a global scale. We do, but we could certainly have much more impact. Anu, I yield back the remainder of my time.
Well, good morning, everyone, and thank you, Rick, even though you just ruined my reputation. So welcome, everyone. Nothing like starting the holidays, right, with a good discussion around climate change. So welcome, everyone. Thank you to all the panelists that are going to be presenting today, to Marjorie for agreeing to moderate it. I will introduce to you the panelists first. Marty Kaplan, who is the moderator. Marjorie, can you just stand or wave or do something? She is the Associate Director of Rutgers Climate Institute, and she leads the Rutgers Climate Institute Program Office and manages a full portfolio of Rutgers Climate Institute activities. In her 30-year career, Marjorie has served both in the government and the private sector, and she is also a graduate of my alma mater, Cornell, so we are bonding around that. And the first panel so the format of the day is going to be two different sessions. The first one is going to be science and technology, and the second session is going to be society and governance. On the first panel, we have Dr. Paul Felkovsky, who is the Board of Governors Professor of Marine, Earth, and Planetary Sciences. He is one of the world's greatest pioneers in the field of biological oceanography. He has won many different awards, including most recently the Tyler Prize for Environmental Achievement. He belongs to many learned societies, including the National Academy of Sciences, and he will be presenting on a topic called Dissecting the Concept of Sustainability and Human Nature. Next, we will have a joint presentation by Dr. Josh Gahut, who is the Professor, Center of Ocean Observing Leadership, Department of Marine and Coastal Sciences. Josh has been recognized for his efforts on translating science-based research in a way that informs applications, decision-making, and management of ocean resources. Josh deployed the world's first integrated high-frequency radar network capable of continuously measuring ocean circulation among Northeast United States. Josh has also been a leader in the use of underwater autonomous glider technology. That torpedo-looking thing on the left side, that's the glider that Josh and Joe were nice enough to bring with them. And he and his students have deployed these technologies around the world to better understand complex marine systems. Dr. Brody, Joe Brody, who is going to be presenting with Josh, is the Director of Atmospheric Research, Center for Ocean Observing Leadership, Department of Marine and Coastal Sciences. Joe is a meteorologist and physical oceanographer with a primary interest in the modeling of the complex coastal environment. His research focuses on using modeling tools to study climate change and working with these tools to further society's use of renewable energy technologies to reduce climate influence. Joe and Josh's session is called Frontier Technologies Advancing the Stewardship of Our Ocean Planet. And finally, in the first session, the presenter is going to be Dr. Bob Kopp. He's the Director of Rutgers Institute of Earth, Ocean, and Atmospheric Sciences Professor, Department of Earth and Planetary Sciences. Bob is a climate scientist, geobiologist, and climate policy scholar. He co-directs Rutgers Transdisciplinary Coastal Climate Risk of Resilience called C2R2 initiative. He's one of the directors of the Climate Impact Lab, a collaboration of more than 24 climate scientists, economists, data scientists, and policy scholars, working to bring big data approaches to the assessment of the economic risks of climate change. And Bob's session is entitled Managing Climate Risks. So I invite now to the table, to all the panelists of the first session, and also Marty Kaplan to the podium. Thank you.
I'll have to respond before we start. I'm going to start now, right?
Yeah, you're gonna start
Sorry,
now.
start on the slide.
Oh, why don't you just get, yeah. Here you are. You got it, you're gonna have to start.
Okay, thank you. Good morning, everyone. Thank you for coming, and thank you all at Global for inviting me. I'm going to talk about the fundamental issues, I think, about sustainability. So sustainability, to me, is a very, very simple concept. The change in a resource over time is zero. Zero, net zero. Okay? if there's a positive increase, if that delta resource, delta time, increases, we're not sustainable, especially if it cannot be renewed. Now, we're in a very, very simple situation. I don't know if you saw the video from the American Museum of Natural History about population growth, which was in the background before you came, or when you came in. It took 200,000 years to go from the beginning of Adam and Eve, out of Africa, to 1 billion people. The 1 billion people mark occurred at about 1860. In 1859, it was the first year of the publication of Origin of Species. It was the first year that Edwin Drake had discovered oil in Titusville, Pennsylvania. And it was the election of Abraham Lincoln, to give you some context. By the end of the century, 40 years later, we had 1.4 billion people. What happened between 1860 and 1900? The civil engineers had separated water that you drank from the water that you pooped in. Okay? That was a major discovery. And it happened because of the big stink in 1858 in London, which killed many, many people from cholera. So the civil engineers in England and then later in Germany and France created clean water that you now take for granted. So we crossed the threshold in 1900. By 1920, we had vaccines throughout the world. By the way, vaccinations were compulsory in England by 1864. They were discovered by Jenner in 1790, and they were compulsory in England. Now, then we discovered, as you know, in this university, and not just in this university, but primarily in this university, antibiotics by Waxman. By the end of the century, with approximately 6.9 billion people. We're now 7.4 billion people. So it took 200,000 years to get to 1 billion people, and it took 200 years to get to 7 billion people. That's an amazing exponential growth. Amazing. We're a very, very successful, very smart animal. So here's the outcome of it. The outcome of it is called the Kaya curve, after a Japanese economist. You have the GDP per capita, and this is in US dollars per person in a log scale, versus the annual consumption of energy in kilograms of oil equivalents per person per year. And you can see it's a log-log, on a log-log scale, this is roughly constant. Now, that's a bad thing, because you have countries like Qatar, which have huge resources of fossil fuels, that are consuming far more per capita on this log scale than, for example, the United States. We're differenced by almost a half a log unit. What we want to do is we want to move the United States and the UK way over here so that we're breaking this annual oil consumption turn. That's really hard. And when you show this curve to any economist, they would say you're crazy. You're crazy if you want to get out of fossil fuels. Okay? So policymakers don't want to tax carbon. They don't want to increase the ability to get alternative fuels into the market. They want to keep this curve going like this because that's the cheapest way of making energy. Now let's just take a look at what the Kaya curve is based on. It's based, I stripped this down very, very simply. It's an identity. So the amount of total energy used is proportional to the population, that's the N, the GDP per N, times the energy per GDP. This is the last term that you really need to solve, the energy per GDP. That's the last term. The energy per GDP has changed by approximately 5% over the last 50 years. It's trivial. It's trivial. So I'm going to give you an example of GDP in the United States in the service function. I'm going to sing you a song, you give me $1. Okay? Doesn't matter how well I sing, you give me $1. You sing me a song, I'm going to give you $1. The GDP just went up by $2. Nothing changed in terms of manufacturing anything. Now, that's not really an important aspect of the GDP and the service functions. But in terms of consumption, how many of you can make a light bulb? How many of you can make paint? How many of you can make wallpaper? How many of you can make an airplane? So that's really where we make the GDP really, really important. Now, I'm going to go into this. This is the liquid fuel consumption, the projections. This is the change over year. This is the change, the delta, millions of barrels per day. Okay? It's incredible. It's all above zero. I got 2 minutes, right? Thank you. This is my last slide. So how many Earths does it take to support the human population today? This is what we're talking about, sustainability. We crossed that threshold in 1970. We're not sustainable since 1970. We're living on approximately 1.5 Earths. Now, 1.5 Earths. What does that mean? That we need another half an Earth. We're borrowing a half an Earth from the geologic past to support us today. And in the business as usual scenario of the Ipcc, by the year 2030, we will have needed 2 Earths. And what is the driver? The driver is number 1, population, and number 2, the energy per GDP. Okay? That's it. Okay, that's my talk. Thank you.
I don't know if I guess I should use that. I tend to talk pretty loud. Loudly. Thank you, Paul. I've never been strong in grammar. And not spelling either. I can never hold my kids accountable for their spelling grades. It'd be very hypocritical of me. So thank you very much. My name is Josh Cohen, and I'm going to talk a little bit, building off of Paul, on this global challenge that he just set for us. This, where we have to make sure that we can provide food, water, energy, economic security to this growing population, and do it while the Earth is undergoing pretty dramatic change. Right? And there are international efforts. This is a Sustainable Development Goals that were set recently, and there's 17 of them. They cover all aspects of human existence on the planet, both natural and the Anthropocene that we are now in, including goals of no poverty, excelling in economics for all, equity. There are goals that involve the natural system, whether it's below the sea level, below the ocean, or above on land and in the atmosphere. And so these are goals that were set forward to be attained by 2030, 10 years from now, to have all of these things come true. And at the international level, there's a recognition that in order to meet these goals, we need to have data and information that can provide the necessary content that would allow for proper policy, good governance, and just monitoring of this incredibly complex system. And as an added component of that, the United Nations just declared that 2021 to 2030 is going to be the year of ocean science, the decade of ocean science. And so there's a realization that in order for data and predictions to support the ability to attain these lofty goals, we need to understand the underlying science that's going into it. And so here's one example of how that's being done on the ocean component of our planet, 71% of our surface. And so this is a map that's put out by JCOM, which is an organization under the World Meteorological Organization. And they are the international body that's organizing observations across the planet, identifying where observations are needed, technologies that can be done. And when you look at this map and you see the coverage across the surface of the ocean, it looks pretty good, right? There's a lot of dots, a lot of different technologies that are providing information every minute of every day to a global system. And that's thanks to this organization. There are many different types of platforms there. These are some of the stats. The JCOM group actually puts out a report card every year. And so this is the report card from 2018 that was just issued in the 2019 document. And you can see there are 86 countries involved, far less than the number of countries on the planet, right? But still an impressive number. Many, many observations. They have an estimate of about 2 million temperature salinity profiles of the ocean that have been acquired in the last 20 years. But if we look a little closer at this map and change it to just the data that was provided in the last month. So this is November of 2019. And what you see is far less points on the map. It's a terrible color. I realize some of you in the back might not see the light blue. These are some of the platforms that are providing information. And the ocean is one aspect of our planet. And it's huge, right? And it's very challenging to measure it. And these observations, while they cover a lot, there are a lot of gaps. And one of the reasons why these gaps exist is because many of the platforms that are being used are traditional ship-based platforms, which are very expensive, high human cost to go on, high just economic cost to run. And it limits our ability to go and sample the ocean. In the last 30 years, there's been a technological advance that's really changed the way that we look at the ocean. It includes a lot of autonomous systems. And in fact, most of the points on this map are autonomous floats that are out there sampling from about 2,000 meters depth to the surface. Every 10 days, each one of those dots comes to the surface and gives data. And there are, thanks to the efforts at Rutgers and other places, there are other technologies, autonomous platforms that are being brought in to fill this in. And this is why it's important as we look at these work. As we look at this, the ocean is fantastically complex, right? It's not just one single fluid that's out there. There is a network of eddies, fronts, jets that are all happening, and this is just the physical ocean. Paul tells me there's some biological stuff going on in there too. I'm not that familiar with it. So there are incredibly complex things that are going on. It's our responsibility to develop systems that can measure at this scale so that we can feed it to Joe, who's going to talk about how we can actually predict.
Right. So my message, and I only have one slide, so I'll be able to fit into the 2 minutes that we have left. All this data is great, and one of the challenges with data, as Josh has just said, is we don't have things like universal coverage of the entire planet, for example. And observations tell us what happened in the past and the present. How do we know what's going to happen by 2030, by 2050, by 2100? And that's where modeling comes in. But the better the observations get, the better the modeling can get. Because you can use those observations either as input into the models, you can use those observations to validate the models, and you can use it to help improve the physics in the models so that you have a better understanding of how the Earth is working. And I have here on the side, that's you probably definitely can't see it from the back, but the idea is models have become incredibly complex, Earth system models. Back when climate modeling started decades ago, you can imagine just a series of small boxes covering the atmosphere, and that's about it, and not even that small. New Jersey and Delaware were basically the same place in early climate models. To the point now where we can model the biological activity in the ocean and how the trees are responding to the carbon in the atmosphere. You can model the ice. We're getting better at things like modeling clouds, all sorts of things that we couldn't do decades ago, but now we can. And so that even more furthers the fact that we need as many observations as possible to do that. And these models, as I said, they help us predict what the future is going to be. And that's where things like the IPCC was mentioned by Paul already, and Bob, you may mention it in your comments as well. The IPCC, we've all heard about the IPCC climate reports, right? They amass this incredible amount of science done by researchers around the planet, including modeling done at agencies throughout the world. And they try to dissect all that information, assess what the human role of climate change is, and then give recommendations on what we should do about it. And so ideally, all of this information that we're getting with observations and with modeling gets communicated effectively to government leaders who then, in an ideal world, make decisions that help us confront these challenges. Of course, there's a lot to be said about how well that mechanism works, but that's the idea here. And so that's kind of where I'm going to wrap this up on our part, is that the more observations and model data we get, the better we have to become at making sure that information makes it to our decision makers, because we're going to be able to make better decisions with the better information. So, thanks.
Great.
So climate change is a risk management problem. And when we think about it from a physical science perspective, climate science is great, physical science is great, that's my background, but physical science and climate science don't tell you all you need to know to manage risk or think about risk. All the physical science can tell you is what the hazard is. It can't tell you about people's vulnerability to that hazard, and it can't tell you about how exposed they are. And you need to know all three of those things to understand how to manage climate risk. So if we can make this full screen, please, and put it on a clicker.
Wait, I'll have to progress it for you because it's not part of the slideshow.
Okay,
Is it working?
can you just go
Once
into
you
full screen
download it,
to slide full
Okay.
screen mode?
Yeah,
Or are we
fine.
stuck? We're stuck in a browser.
Yeah.
Oh, okay. All right. Well,
Okay.
let's do this right. Where do we?
It is downloaded on
Oh, it
the
is
desktop.
that.
Yes.
Okay. If you could open it on that. So what we need to do then is work together with the physical scientists, but also with social scientists, with engineers, with people on the ground, to understand what the risks are associated with those physical hazards and how to manage them. So I want to give you two vignettes, and ideally we will do this in full screen.
We have plenty of time.
Control L. Yeah,
Control F.
just down there. Yeah. Great. So two vignettes. So in my bio, it was mentioned that I'm one of the directors of the Climate Impact Lab, which is a collaboration between Rutgers, Berkeley, and Chicago, linking together the physical scientists based here with economists and data scientists to learn about that translation between hazard and risk. So I want to give you one example of our work, because it's a global example, looking at human health. So what we've done in this study is built what we think is the largest sort of self-corrected data set of mortality impacts in the world, right? So we're looking at mortality in the world, right? So we built this database with the regions shown here, which covers about half the world population, in some cases about 30 years, and our goal is to learn from that how vulnerable people are to exposure to a day of extreme heat or to a day of extreme cold. So that we can then go and learn how that evolves over time as countries become wealthier or become adapted to climate, and project forward what the potential risks are to human health from climate change that we have to manage. So just to so the sort of thing you can learn from applying these big data approaches. So these figures here, which you can't read because see where I'm pointing to because of the screen. Right here we have a matrix that's looking at the effect on mortality of exposure to a day of a specific temperature. So, if we see under 35 degrees C here, that's the effect on mortality. This is age over 64 of exposure to a 35 degrees C day. And we've broken it up based on county level income around the world, low, medium, high, and climate exposure. So what you can see is that low income places have more severe impacts in terms of health, and to hot days, and cold places have more severe impacts. So people get adapted. They invest in air conditioning if they're wealthy, for example. They take other adaptations.
Was the bottom the mean climate, cold, temperate, and hot?
Yeah, those are mean climate. So what we're going to do is take, say, physical hazard projections. In this case, is exposure to days of different extreme heats from those climate models that Joe was talking about. And just to show you examples, so here is historical average summer temperatures from 1986 to 2005. Here's a median projection for a high emission future of what the average summer temperature is going to be. All right, and so let me just flip it back and forth again so you can reach that. That high emissions future, it's a world where we're looking at 8 to 9 degrees Fahrenheit of warming by the end of the century, is a much hotter world, and we have many more days of extreme heat. So we can combine those projections with what we've learned from looking at data over the last 30 years to look at what the mortality risk
associated with climate change is. And so this is our projections of the impact on mortality of these changes in exposure to heat and cold. So we see it's not, first of all, a uniform picture. It's actually the cold places. See, the reduction in number of cold deaths outweigh the reduction in number of heat deaths. But if we look at the story at a global scale, so here, what we're showing you, first of all, just from reference on the right side, are some other common killers, right? So cardiovascular disease, cancer, infectious disease, injuries. On the left, these are the deaths in low-income, middle-income, and high-income countries, and hot, moderate, and cold climate countries. And the light shaded are sort of converted into equivalent terms, the expenditures on adaptation. So what's the basic story here? People in low-income countries die from climate change. Those in wealthier countries spend money to adapt. That's point one. Point two, if we get onto a moderate emissions trajectory, 2.5 degrees Celsius of warming by the end of the century instead of 5 degrees, we cut that mortality risk around 80%, although we're still looking at a death rate that's comparable to traffic accidents in the US today, right? So there's substantial risk. Mitigation helps a lot, this effect exacerbates existing inequalities. One short second vignette about sea level rise. Right now, about 400 million people live within about 6 feet of the high tide line, areas that are potentially vulnerable to permanent flooding from sea level rise over the course of the century. That's a lot of people. And yet, we don't actually have, despite all of these improvements in climate models, we don't actually have very good constraints on what sea level rise is going to be at the end of the century, particularly in a world in which emissions continue unconstrained, because there's a lot of physics involving polar ice sheets that we don't yet understand. Okay? These numbers for high-end projections in a high-end, high-warming world have bounced around a lot over the last few years. And yet, we have to make decisions today about how to deal with these long-term risks, because in some cases, decisions about the built environment affect vulnerability 100 years from now. Right? Flooding, the stability of the electric grid during Superstorm Sandy here in New Jersey had been affected by decisions about where to place switching stations and where to place generating stations 100 years previous. Thomas Alva Edison affected our vulnerability to Sandy. So when we think about the built environment today, we have to be thinking on these timescales. And how do we, just a picture, here's Miami. This is 2 feet of sea level rise, this is 3 feet, this is 6 feet. And we might, under a low emissions world, some approaches to estimating how likely 6 feet is would give you 1% chance, and some of them will give you 40% chance, right? And yet we have to make decisions today. And so that requires close coordination, close collaboration between scientists who are learning about how to refine these uncertainties and people on the ground. It requires an adaptive, flexible approach, one based on thinking about contingencies. And that's something that we've been working on at Rutgers, and I want to acknowledge people like Marjorie who've done such a great job in building connections here in New Jersey between the science side and the stakeholders on the ground who are making decisions. And so one of the things we try to do here at Rutgers is to train scientists to work together with social scientists and engineers and urban planners and stakeholders, because we need those people trained to interact in that way in order to deal with these deeply uncertain problems. And so that's the goal of our Coastal Climate Risk and Resilience Initiative, which is entering its 4th year as a graduate program here at Rutgers. Thanks. Sorry.
That's okay. Well, good morning. I'm going to ask you guys to get together because we only have one mic, and I'm going to have to sort of be a little bit like, I'll date myself, Phil Donahue, or one of those people. Nobody will know who I'm talking about. But anyhow, good morning. Paul set the stage describing this great paradox of how human discovery and ingenuity has resulted in this huge challenge to humanity. And Josh and Joe have described the significance of continued human discovery to address this challenge. And Bob talked about the threat multiplier of climate change and the need for quantitative data, but also to be flexible, to have a framework for addressing deep uncertainty. So the way we're going to do this today is that I'm going to we'll have a few general questions, and if we have a little bit of extra time, because we were running ahead, but I think we made up for it, then we'll open it up to a little bit of Q&A, but then we will be doing Q&A with everybody, so you will have your chance. So don't worry about that. So these are huge issues, right? And so one of the questions I might ask you is whether we're at a tipping point, or at what point is there a peril in controlling the planet for humans and other things, other living things, and what would that cost be? And I might also ask, as part of that, if Paul, I think part of this might be on folks' tongues, is if you might want to elucidate a little bit more about this, how many Earths does it take to save humanity, and how you came to that. I don't know if you can get to Paul's fourth slide, but it might be interesting. So I'm going to put you on the spot, Paul, and I'm going to give you this first. How's that?
Okay. So anybody that has ever looked at a microbial growth curve realizes that there's an initial phase, there's an exponential growth phase, and a stationary phase, and then actually, if you look at the modern textbooks, there's a death phase. That won a Nobel Prize for Monod, by the way. Where are we? We're still in an exponential growth phase. What's limiting in a microbial culture is a resource such as, for example, in the case of most common bacteria, glucose or some other carbon source. What's limiting us? So let's take the issue now in terms of the nexus between energy, water, and food. That's not really a nexus, actually. There's a hierarchy. So the entire human population today produces and consumes about 15 terawatts of power on this planet. That's the production of energy, total. Solar, electricity, everything. We're going to have, let's say, right now, about 1.4 billion people don't have a wire to their house. So they have no electrical power. If we go up to 9.5 billion people by the middle of the century, that means that we would need to supply, if we were to supply everybody with a comparable power to somebody in, for example, Venezuela or Chile today, about half the power consumption that we have. We'd have to produce approximately 30 terawatts of power. That's double the power that we're producing today. So that's number one problem. Now, to put that into perspective, solar output is 150,000 terawatts reaching this surface of this planet every year. So 15 to 150,000. We're trivial. We have an amazing ability to capture solar radiation, to use wind-generated radiation, which I'm surprised you guys didn't talk about, to do all kinds of things that are renewable to displace fuel that we consume, and to replace fuel for heavy transportation, which we need for trucks, for trains, for airplanes, with biofuels, which are sustainable. So we can do that. Now, if I give you energy, I can give you water. And that's not it's a no-brainer. For example, Israel had one lake, one freshwater lake. The largest freshwater lake in the middle of the Middle East was Lake Kinneret in the north of Israel. It was the source of water for the entire country for years, for many, many years. Israel has built out 8 desalination plants because it has energy now, because it discovered fossil fuels off of its coast. So there's no problem with water. Qatar, United Arab Emirates are building huge desalination plants based on solar energy. So they will have water. If they have water, they have food, to first order. So I'm going to ask you, if I provide you energy, and I provide you water, and I provide you food, what is going to lead to the top of the curve? What is going to be limiting for human population growth? And here's where we have a very fundamental problem with the two-planet problem. I can reach into my pocket here and take out a piece of paper. This one is got a picture of something or other on it. This guy, the picture of a president. Rick gave me one of 5 billion years ago, a few years ago. This is 5 billion Zimbabwean dollars. 5 billion, I'm the billionaire, okay? All right. And then I have funny things
He
here.
has money, I don't
Here's
have it.
50 billion now.
Oh, wow. And then I have this, right? This isn't even a picture of anything. All right, so there is a thing. If I go to a squirrel and I give them 50 billion Zimbabwean dollars, or I give them $1, I give my squirrel $1. The squirrel has no idea what the heck I'm doing with it. Try to eat it, okay? So as an animal, we have made up an economy that's based on premises that I will give you something in return for something that's based on a value of something. But what is the true value of the something? The true value of the something is the photons that hit the planet that make reductant, that make the food, that make the fuel, that make the ability to make the plastics, to make the paint, to make the concrete. So that's the Earth. That's the one Earth. And this stuff makes the two Earths. So we're living in a fantasy land of two economies, a human economy and a real economy. And until that is coupled, until those concepts are coupled, we can live on 2 Earths and 3 Earths, but it is not ever sustainable. It will not ever be sustainable. So marrying the economy of human beings with the economy of the planet is really the challenge. It's not just in fuel. It's not just in climate. It is not. It's in everything we do that transforms the processes on this planet to make us comfortable. Okay? So you think about that, because plastics actually, well, they have a very long lifetime, thousands of years, are only 2% of the waste of human beings. You think about it. Think about how long that asphalt for all the roads and all that concrete and all these buildings will last. That amounts to about 90% of the human waste on the planet. I'm not even now talking about the transformations of rare earth elements and other things like this. So the Anthropocene is a garbage dump. That's really what it represents. It's a garbage dump. The atmosphere is one place to put the garbage, the ocean is another place to put the garbage, and land is another place to put the garbage. So this is not sustainable. And it's not just climate, it is not just health, it is the entire system of how human beings operate and function.
Thank you, Paul. Thank you. Do you want to talk about cleanup?
Well, so, Paul set up that really optimistic view. Thank you, Paul. And I guess if I'm thinking of tipping points, I would raise one more, and it actually feeds off of one of Paul's comments in his slides about how smart we are as an animal on this planet. And I think about the technology tipping point. And in the context that we were talking about is information. Bob did a very nice job of talking about how that information could feed an understanding of what the risk might be. Joe and I have been working a lot on how information about our natural planet can help in understanding how we deploy offshore wind or other renewable sources, how we manage a wild fishery on our coastal waters just offshore. And the tipping point right now is that these technologies are becoming more widely used. They're becoming more autonomous. They're becoming even more self-governed, right? And so that does two things. One, it provides more information. It also gives access to places and cultures that may not have had access to observations of our planet that now do. And that tipping point, I think, can only be realized if we have the ability to turn that information into something that Bob and his team can do into a decision that would impact governance or policy or even human behavior, right? And so the tipping point, I think, in order to address these challenges that Paul has laid out is how do we properly take advantage of these technological advances, speed up the ability to get them in the earth, whether it's the atmosphere, the ocean, or the land, and then turn that into something that is actually actionable in decision making. So that would be from my perspective, the tipping point to address the big challenges that Paul has laid out.
Yeah, so I'm going to take a position that sort of fuses the two of those and say, I can talk about tipping points in the physical climate system, but I think what we really want to talk about are tipping points in the human system, because I hope we're at a tipping point. Because of, Paul's shown, we haven't tipped the population curve yet. And so we have a global ecological crisis, we have a global climate crisis. We are also developing technology that in principle can help us transition into a way where we are getting lower carbon emissions, lower ecological resources per dollar of GDP, so that we can maintain people's prosperity without having a global collapse. But we're also having another crisis, which is a global crisis of democracy. I think that these things are not disconnected. I think one of the reasons why we're seeing this democratic crisis all over the place is that we built a global civilization, and so everything affects one another. And so what we need to do, I think, is find a resolution to all of these crises together that leverages the information that we're getting, that figures out how to use the great science that is happening, the technology that's enabled that to inform democratic deliberations in a way that gets us out of this climate and ecological crisis. We don't have a lot of signs of that yet, but we have a lot of little things happening over the places. It does look like global CO2 emissions growth is slowing, but it's not even plateauing yet. So I'm hopeful that we are at a tipping point where we will sort of leverage technological change, where we will resolve the democratic crisis to establish governance mechanisms that can address the climate and ecological crises.
I'll just chime in really quick to add to some of that. In terms of tipping points, I agree with Bob. I think the tipping point now for us is what are we going to do about it, and when can we get there? And I'll connect this back to Paul's economic example. What is one of the main reasons we don't have a huge amount of renewable energy? It's because people think it's too expensive. And that it's cheaper to continue to drill for oil and to use natural gas, which economically maybe that's still true. But the technology is getting cheaper, and we're getting to that point now. Like this I think it was last year in the United States, installation of land-based wind was greater than any other energy installation in the country because it's gotten so cheap. In Europe this past year, Germany was able to build an offshore wind farm, which is very expensive here in the US. They were able to build it without any government subsidies and still break even. And so the technology is getting cheaper. We're getting there, but we need to get there faster. And so it's up to all of us to push this along and help it succeed. So.
Thank you. So we are here at Rutgers Global. So it would be, and this is the science and technology panel. So I'm just wondering if you guys would like to pontificate a little bit about how the international community is organized to ensure that we are collecting truly global data that can address local needs. Does anybody want to take that on?
Yeah, thank you, Marjorie. So I've had a chance to travel around a lot of different places, and one of the things that strikes me is how important those international efforts are, particularly on the technological deployment and monitoring. The term I heard was more general than I'm accustomed to because I live mostly in the ocean world, was Earth observations. And this EO acronym was all over the place. And I was at a meeting 2 weeks ago in Portugal where there was a lot of participation from technologists in Europe as well as in Africa and in North America. And the one thing that struck me was the importance of that sort of UN overarching, those are very lofty goals, but those sustainable goals, there were presentations from all different countries all around the world. And I think every single one of them had those sustainable goals as like their first slide, right? That we're using these goals as a template and a framework. And so there's this organization that's happening at the very local level in some cases that is all under this big umbrella. And so if we're all working towards those common goals, there's instantly a connection that can be made. And what surprised me, and I think is a great credit to Rutgers Global, is that in those conversations, I was speaking with researchers from Namibia, from Nigeria, from Tanzania, which I learned. I always thought it was Tanzania, but Apparently it's Tanzania, so that was interesting to learn. But these researchers and technologists already had connections with Rutgers. And I was speaking with faculty at the University of Namibia, and they said, oh, we already have an MOU with you guys. We need to start implementing this. And so there's these important MOU activities that the university is undertaking that we can leverage that are already in existence that allow for the application of technologies that we're doing right here at Rutgers to feed processes all around the world. And it's through that, I think, more of a grassroots effort that we all fall under this big umbrella of the UN goals that we can all work towards. And so that international piece is critical.
So I think about this in a funny way. Obviously, the major centers of population growth in the coming century will be Africa and to some extent Latin America. What is happening in Africa? In Africa, in sub-Saharan Africa, infrastructure, power, transportation, in many other aspects is being fostered by China. China has made major inroads in Kenya, in almost all of sub-Saharan Africa. And China is engaged with their engineers and their universities. And they bring African students back to China to educate them. And they develop companies within Africa. The United States is not engaged. And universities of the United States have vested interests, obviously, in trying to do that, but we need much, much more support from our government. The future of the country, of this world, is not dependent upon only the future of America. It's obviously an interconnected aspect. Now, the second aspect I'd like to point out is that China is not a democracy. By the way, if you're interested in the rise of democracy, Jacques Barzon, who was Dean of History or Dean of Humanities at Columbia and was one of the great professors of history at Columbia University, wrote 500 Years of Western Civilization from Dawn to Decadence. If you haven't read that book, it's an amazing book, From Dawn to Decadence. From Voltaire to the present world, he predicted it. He died about 5 or 6 years ago at the tender age of 106. The aspect here is that China, not being a democracy, can change its power supply. If they decide they want to build 300 nuclear power plants in the next 10 years, they don't have to ask permission. They'll just do it. They just do it. Now, there are 420 operating nuclear power plants in the world today. 420. And they're in all countries, many, many, many countries. You wouldn't think of it, like Slovenia. I mean, you know, all kinds of countries. Nuclear power is anathema in the United States because of 3 Mile Island. It's crazy. It's crazy. So I just think about where we have power in this city today. Most of the power is supplied by 2 nuclear power plants down in the South Jersey. They will go out of commission probably within the next 10 years. Ralph Izzo tells me to replace one of them would be the entire valuation of PSE&G. So when they go out of commission, that's it. That's it. We have to really rethink the way we do business to make things sustainable. Now we have I'll just give you a very, very quick idea here. We could make another type of nuclear power plant that's based on thorium, where the output is uranium-233. It has a different fuel supply. Where are they being? They were designed in the United States, by the way, just like maglev trains. Where are they being built? In India. Where are maglev trains being built? There are 2 physicists at Brookhaven. When I was a student, when I was on the faculty there, 2 physicists were stuck in a traffic jam from New York City out to Long Island, in the Long Island Expressway. And Danby turned to the other guy and says, why don't we build a magnetic train that goes across a magnetic field right over the highway that can run at 300 miles an hour? They patented it. The Germans tried to build one. They had one crash, they gave it up. Where is it now? It's in China. So, I'm just saying that we need to be a little bit more daring than we have been. One last thing. Just think about this. So oil was discovered as a well in Titusville in 1859, as I told you, by Edwin Drake. In 1878, Daimler created the first internal combustion engine using a waste product from the distillation of kerosene. That became gasoline. By 1900, Ford had already started to build plants using an assembly line. By 1910, there were tens of thousands of cars in the world. By 1920, cars were everywhere. They had displaced horses. So within a short period, we had transformed the entire world's technology. So when we say we can't do that, how many of you had these as a kid? I mean, this is, if Alexander Graham Bell came back from the dead, he wouldn't understand how this works. If Thomas Alva Edison came back and he looked at any power plant in the United States and said, that's exactly what I designed, with a few little whistles and bells. So the technology we have today for power, for transportation, is basically that of 100 and 120 years ago. We know how to change it, we just don't do it. Okay, stop.
Did you want to say something? So I'm going to take a prerogative. We have just a few minutes, but we do have some students here. And I'm going to ask the second panel the same question, so you're all on guard now. You can get your answers ready. So these discussions about climate and sustainability, they can seem paralyzing. And this can seem that way, correct? So I'm going to ask you to provide some glimmer of inspiration or optimism, either by sharing one exciting moment from your work or one trend you're observing.
I'll take your look at me as I should go first.
Because I know you can do it.
So, tough. So there's a lot of actually glimmers of optimism, I think. But the one I'll choose is about 2 months ago, the global community on ocean observations got together in a meeting called Ocean Obs, and it was 19 because it was held in 2019. And it was the third of these types of meetings that were held. And it's for the international community to get together and say, what's next? 10 years ago, what was next is they developed a framework for how we coordinate ocean observations around the planet. And every time this meeting has been held, it's had the same exponential growth equivalent to, I guess, our population. But we're seeing that interest grow. And the inspirational thing I'll say is there was a speaker at the panels were made up of a lot of experienced folks, except for one. There was one panelist who was a young lady from New Zealand. Her name was Riley. I liked it because my daughter's name is Riley as well. And so I could share this with her. But she was 18 years old, and for the last 5 years has been a huge voice in New Zealand and now around the world on small things people can do to make a difference. And her approach, she was so impressive on this panel, and it was so inspirational to me. I shared it with my daughter, and so I say that's the optimism. Seeing the students that are in here, you have such great energy and such great effort to make a change and to take that on, and to see Riley as an example of how someone who was just interested in putting out a video on YouTube about how to clean up the ocean by walking a beach could do that and now be on a panel at this international meeting among giants, quote unquote, in the field, and she was right there with him. And so I think it's her that inspires me now.
So I think scientists have been sounding the alarm about these issues for a very long time. I was 7 years old when the first congressional hearing on climate change was held. And the thing that gives me hope that is new over the last couple of years is that I'm starting to see people not having simply a dystopian vision of a future in which we're tapping 5 Earths and we've had a sustainability collapse, But we're actually starting to have a public discourse about what a world in which we resolve these problems might be. And scientists have something to contribute to it, but we only have something to contribute to it. We can't be the people driving it, right? Again, we can say this is what's happening. We can say this is what's likely to happen if this happens. But what we need is this mass dialogue. We need a visions of a future in which we resolve these problems. And so I am very inspired by people like the students who are pushing things like the Green New Deal in the US and Europe, by people like the climate strikers who are trying to recognize that we have to do something, but also recognize that we need somewhere to go and not simply to point out how terrible everything is. And so that's one of the things that gives me hope.
So I can see every once in a while I give a senior honors lecture in chemistry department. I'll give you an example. My friend Dan Nacera would say, if I gave you one swimming pool worth of water, I could power the city of New York for a day, if I could split the water. So one kid somewhere at 2 o'clock in the morning in some university probably will figure out how we can do this now. We can split water with just the energy of sun with artificial catalysts. We don't do it very efficiently. If we make that process efficient, it'll be transformative as Drake's drilling of an oil well, if not more. So there are ways that science can contribute that are fundamentally transformative, equal transformative to solar power or a cell phone or computer or transistor, if not more so. Now, I just want to make sure that we understand the role of a university. The role of a university is to make brains. That's what we do. We make brains. We should challenge our students to be as creative and daring as they can be. We should not be training students. We should be educating students. We should be making sure that our students really question themselves as to what they can be when they grow up. And remember, we're always growing up. We're never staying still. So I think one of the things that this university fundamentally has to do is to not worry about whether a student gets an A and goes on to become a medical doctor. It's whether the student gets an A and understands 3 years later what the core concepts in the course were. Okay? So that is really where we have a challenge at this university, I think, because then we can create brains that go out and become transformative. Thank you.
So I'll be very brief, and I think that it's a twofold thing. I actually mentioned this earlier, right? That here in the United States, just last year, we installed more wind than any other power source, and that's with a federal government that, shall we say, is not as in favor of renewable energy as it could be, and that still happened, which I think is remarkable. And so imagine what we could do if we had more support, right? And that goes back, that connects back to the students and the younger generation, in that they are helping to steer this discussion now, way more than when I was a student, which wasn't even that terribly long ago. I was an undergrad here about 15 years ago now. Oh, it's gotten bigger. And I remember when I was an undergraduate here, even in an environmental science class, there was discussion of, is climate change just hype? And I mean, at the time I thought that was crazy then, and it's definitely crazy now. And it's completely changed now. And the younger generation is steering us in the right direction. And I think we need to continue to foster that here at Rutgers and at other universities. And I think that's how we're going to get there. With the voices of the younger generation saying, look, we're the ones who are inheriting this disaster. Let's do something about it. So I'll leave with that.
Well, thank you. I think we should give a round of applause to this amazing panel. And I think let's turn it over to Anu to introduce the next panel. Great job. Thank you. No break. We're talking, people are talking. We will do questions for everyone. Yeah.
Thank you again to our first panel on science and technology. Our second panel is going to be on society and governance. And the panelists that I'm going to invite to the stage now are Simi Payne, who is the Associate Professor at the Department of Human Ecology, School of Environmental and Biological Sciences, and she's also a professor at the School of Law in Camden. Simi studies global governance of the environment and natural resources and the evolution of international law, with a focus on climate change, ocean resources, and protection of the environment in relation to armed conflict. She has appeared as a counsel before International Tribunal for the Law of the Sea, and as an expert before World Court on the legal aspects of environmental valuation. She is the chair of the IUCN World Commission of Environmental Ocean Coast Coral Reef Specialist Group, and also an elected fellow of the American College of Environmental Lawyers. The topic of her discussion will be climate change governance. The second panelist is Robin Lichenko. She is the professor and chair, Department of Geography, and co-director of Rutgers Climate Institute. Robin's research intersects the fields of economic geography and human dimensions of global environmental change. Her work examines how and why processes of global economic and environmental change differentially affect cities, regions, sectors, and implications of these processes for questions of vulnerability, equity, and sustainability. Robin's session is entitled Bringing Equity into Climate Change Adaptation. And finally, the third panelist for the session is Dr. Kevin Lyons, who is Associate Professor of Professional Practice, Supply Chain Management Department at Rutgers Business School. Dr. Lyons conducts research on developing and integrating global environmental, social, economic, ethical criteria and data into supply chain procurement systems and processes. He has won many awards. He is the recipient of the Sierra Club Annual Professional of the Year Award, New Jersey Governor's Award for Environmental Leadership and Excellence, and a recipient of 2 NSF grants. His topic today will be green purchasing and supply chain management. So I invite all the panelists to the table now to begin the second session.
Just jump in. Okay. No, I don't have any slides. And is this, yes, it is.
Hi.
Well, thank you for the invitation. And the first panel was a terrific setup for what I want to talk about. So it was, we left on the note of we know a lot through the science, and what we need is better governance. And it was certainly not heartening to see when the climate change Conference of the Parties, the 25th meeting of that group, ended in Madrid on Sunday. They had gone over 40 hours into overtime, and they had still not managed to do all the work they needed to do. They did make some progress on some aspects of the agenda for global climate change governance, but they ran into serious obstacles. And some of those were the obstacles foreshadowed by Paul Falkowski's description of what's at stake. And when it starts looking like a zero-sum game, and you might have to give up your own country's well-being, your own access to food, water, and energy in quantities as large as you want, that becomes very problematic when you're in a negotiation. So about 27,000 people were there. About half of those were government delegates. About half were civil society representatives and the press. I think many people feel when they look at that, that the international system isn't helping us. And we should simply turn to what can we do locally as individuals, maybe through states. If you're in the United States, you're not probably thinking through the federal government. I think it's a different, I take a different view on that. My view is that climate change is an extremely difficult problem for the reasons that you heard already this morning, and that the international issues, working out international agreements, is commensurately difficult. I think the value is that we keep talking, that the 25th meeting happened, that we will keep talking. The international system provides us with a way of getting together and trying to cooperate, of trying to update the science. And that is going to be very important. I think the other part of this is that although the US will be out of the Paris Agreement next fall, November 4th, the day after the US presidential election, nonetheless, activities are taking place at other levels. There are still jurisdictions, including local, state governments, that are making efforts to meet the Paris Agreement goals for the United States. And they represent a significant percentage of US greenhouse gas emissions. In fact, if the US government was fully committed to the Paris Agreement, we would still need to be working through localities and states, because that's where the hard work of reducing greenhouse gas emissions takes place. So I think the other thing we want to think about is that in addition to those local and state efforts, which are probably we're more aware of those than we are of the fact that there are other international efforts going on. The global Earth observation system is a critically important part of that, but there's a legal approach too. So the legal approach, which I'll just briefly introduce you to, is a new treaty. It's the only major treaty being negotiated at the United Nations now, and it is for the conservation and sustainable use of ocean biodiversity. We've been participating in that treaty, bringing expertise from Rutgers to the negotiating floor. I lead a group at the International Union for Conservation of Nature, which is an intergovernmental organization, and we provide expert counsel to the delegates at that treaty. It's at the United Nations, and I'm hoping that I'll be taking some students with me to at least one day of the negotiations this spring during the quote-unquote last negotiation session. I don't think we're going to finish, honestly, in April, but who knows. So there are these ongoing efforts, and I think we need to keep pushing that. We need to not lose confidence that through an international conversation, through efforts to cooperate globally, we can make some progress on these issues. I think I'll leave it there because I want to leave enough time for us to have a conversation as well later. So.
Hi, everyone. So we've heard, I think, some really excellent arguments for why climate change is a scientific challenge, why climate change is a governance challenge, why it's a technological challenge. But I would also, in my talk, I'm really going to argue that it also, really fundamentally is an equity challenge. And so when we think about climate change, and if I asked why is climate change an equity issue, if I asked everyone in the room that question without this slide up, they would say, well, it's probably, really along the lines of we have, these tremendous differences in who's driving climate change, which countries are dominant polluters, which countries are sort of causing the problem, which countries are the most vulnerable, and at sort of at that national scale. And I would say that that's a critical issue, and in some ways, I think not really paying much more attention to these kinds of equity issues is one of the factors holding up sort of our holding up the progress on the issue. But in terms of sort of the kind of equity challenges of climate change, I'm also going to really make the case that it's an equity challenge in terms of going forward and how are we going to be responding. And my own work is really fits much more in the kind of the space of climate change adaptation. So we have, sort of significant vulnerabilities, identifying who's most vulnerable, identifying opportunities for action, opportunities for sort of what we call adaptation or building resiliency and so forth. And that's where we also really have, I'm going the wrong way. We have really, these tremendous equity challenges and these tremendous adaptation challenges. So when we think about climate change, it's an equity issue, but it's also really, in many ways something that we're all going to be having to sort of deal with, having to adapt to, having to change the way, from everything in terms of the energy piece that we talked about so eloquently in the first panel, but also in terms of our way of life, in terms of even the assumptions we're making about where we can live. How long can we live in the cities that are facing really significant sort of challenges around sea level rise and so forth, the Miamis that we already saw, but even the New York Cities and the coastal New Jerseys are also in that bullseye. And so really sort of kind of bringing together, sort of we all are going to have to adapt to climate change. It's something, Rutgers University is starting to think about as well. We're sort of really starting to think more forwardly about that. New Brunswick, of course, but trying to put those two pieces together and say, well, it's an equity challenge and we're going to be doing adaptation, and then sort of how do we build equity into the process of responding to climate change, and where can we build equity, where are those opportunities? And so just in terms of some of the work that I've been doing, in my lab with my students and so forth, but also sort of some of the work happening at Rutgers more widely through our Climate Institute and so forth, is to really try to identify those kinds of opportunities to say, where can we sort of build in equity processes? Where can we sort of think about sort of even the whole climate justice movement? How do we make sense of that? We can make sense of that as sort of a call out for recognition, a call out for having voices of places that are being hit hard by climate change, groups that are being hit hard by climate change, want to be at the table. They want to be in the room making decisions going forward. And so I think that, in terms of yes, it's a scientific issue. Yes, we're doing an excellent job on advancing the science of climate change, but I think advancing the governance and thinking about almost really new ways of governing in a space of a really dynamic, uncertain environmental baseline. How do we sort of even get there? How do we do that? And so I think, I'd love to further discuss this as we go through our comments, but I think in our role as educators, this is kind of one of the spaces that we're really in, that we have these opportunities to broaden out how students are thinking about climate change, so that we're not just teaching them this is an environmental problem, and when you go to your next class, now you're in your English class and you don't need to think about that because that's just an environmental problem. I think really giving them many ways of thinking about climate change and many entry points, and climate change, environmental change, sort of I kind of mash all those pieces together. So I'll think I'll end there.
So I want to thank Global. We're like strategic partners. That should be a part of your department now. But I'm in the business school, and I have a new business idea, which my colleague Magda probably will laugh at. And that is that these 5-minute lectures, I can start doing 5-minute lectures, and then you can get an entire college degree in like one day. So basically everybody that's been up here has basically solved the world's problems. So I'm going to talk about supply chain and do it real quickly so I don't bore you. And how this concept of environmental impact can be integrated into that, and I'm going to show you an example from a company that we're working with Merck. So in the top left-hand corner is a very simplified version of the supply chain. Thinking about a consumable product, something that you might use on a day-to-day basis, like a personal care item. So there's raw materials that need to be extracted from Earth. If it's a product that contains raw materials, something that might be on a farm, or something like rare earth minerals that make up a Tesla battery. Okay, and those components come together as part of the supplier negotiations as far as contracts. It gets manufactured into a product of some sort, and then ultimately it gets sent out to a retailer being like a Target or a Walmart or a place like that, and then there's an interface with the consumer. So what I do in my research is I look at the end-to-end environmental impact of that, but more specifically, the bottom left-hand picture is the waste, okay? So we're a very wasteful society, everybody knows that. But what can I do as a supply chain researcher and practitioner to minimize not only the waste, but the environmental impacts of that process of all those steps that it takes to get a product to the shelf, okay? The bottom line is that it's gotta be there, it's gotta be cheap, and the consumer has to be able to consume it. But there's all kinds of not only physical waste, but all the emissions and all the fuel and the energy that it takes to actually make one product. So what my students do in my class is throughout the entire semester they investigate individual products so they can understand that products themselves tell a story about the environment and climate impacts. Over on the top right-hand corner is just a simplified version of a project that I've worked on over my career with Levi's. Something as simple as them coming to me and saying that we want these pair of jeans to be environmentally responsible. But when you look at the process, the cotton being extracted, the manufacture of the product, these jeans are actually manufactured in 3 or 4 different countries. It comes back together and then the zipper is actually manufactured someplace else and then ultimately gets to the consumer, and then they have to decide once they, well, if they're like me, I wear my jeans for like 25 years, so I'm a little bit an anomaly, but ultimately it becomes waste. And now with this term called fast fashion, if you have heard about that, clothing that goes out of style within literally months, and I'm on to the very next thing. So we have issues in this particular case when it comes to fashion and textiles that we're investigating as well. So I'm not going to talk about this, but I wanted to show you, even though I simplified what a supply chain is, there are a lot of steps involved. And when folks come to me and say that, hey, we want to green this process or make it more environmentally responsible, I literally have to go through every single step in the process in order to tease out the possibilities of environmental impact. So what does it really all mean? It means that you have to start to design products with the environment in mind, all right? So don't wait until it becomes a waste item. The designers and engineers that we're working with have to start to think innovatively about, does this product need to have as much waste as it has in order to get to the consumer? So some of my Rutgers colleagues have been instrumental over my 30 plus years here at the university to think about that. The Rutgers University furniture, for instance, very simple example. Gets shipped in blankets, okay? Why do we need the big box? Why do we need all the stuff that goes around it? We just want the chair, all right? So we've been able to work with companies to eliminate waste as much as we possibly can. Thinking about the environmental health issues of the people who have to touch the product along the way and what's concerning to them. The reason why we switched to bio-based cleaning products is because of what's affecting the health of our employees. So one example quickly is Merck. We've been working with them for the last 8 years. So now sustainability is at the core of their business decisions. Okay, so you can see they are a health company, all right? But it's important to their employees and the people that they touch that ethics and transparency and sustainability are part of who they are. And these are just some of the things that they have incorporated now into their business strategy. And as you can see, it's more about the customer, obviously, but what can we do to incorporate sustainable practices and still get the profitability that we're looking for? Can we do social responsibility and environmental responsibility and still get a profit? And then lastly, just a little collage of some of the projects that our students are working on with various companies that you know, getting into those companies and affecting change directly with who they are and how they produce goods and services that ultimately reach the consumer. And that's all the time I have. Thank you.
Thank you, Kevin. So, Simi gave us a 50,000-foot view. of global governance, and Robin spoke about equity and Kevin spoke about the private sector. Ooh, complicated. So before we go any further, I think I want to give Simi and anybody else on the panel just an opportunity to elucidate a little bit further on your key points because you hit so many things. So I thought that might be helpful to folks.
Thank you for that opportunity. I'd like to emphasize and maybe unpack one detail from the Ocean Treaty because we have such a significant presence here in marine science at Rutgers. And so maybe I should give it a little more context that, and I'll just say this in one sentence, that the ocean is not only being seriously affected by greenhouse gas emissions in terms of acidification, warming, and deoxygenation, but it also, the biodiversity, the life in the ocean is part of that system. So it's the physical and the biological combination, interrelationship that's so important. And that was why I thought the Ocean Treaty is very relevant to the climate change governance context. There's one other point I'd like to make out about this. So in the treaty, what we do is we not only say who gets to have what, sort of an allocation property approach, but we also think about how to protect the ocean and how can we put institutional mechanisms in place. And to do that, and to actually run the system once we set it up, it's a management system. Once we want to run it, we've got to have input from scientists. So we have a lot of international fisheries organizations that manage tuna stocks or regional fisheries in the South Pacific. A recent study said that 17% of the time, the fisheries managers in those treaty organizations accept the advice of the scientists they have within their system. 17% of the time. The rest of the time, they do whatever the hell they want to. So one of the things we're doing in the biodiversity treaty is figuring out how to put in scientific advising in a way that it won't be politicized too much and that it will be listened to in decision making. So really critical, detailed aspect, and that's where the lawyering comes into this connection between the research, the social recognition of what we need, and how we get to actually making it happen.
That's great. Did anybody else want to elucidate a little bit further on what you spoke about?
I just wanted to say that I forgot to say thank you to Rutgers Global for organizing. I didn't plan on saying that first. I wanted to thank Rick Garfunkel, Rick Lee, Anu, where are you? And of course Marjorie for moderating. Thank you.
Oh, you're welcome.
Yeah, just real quickly. I had talked about products, but the other thing that these corporations and organizations like Rutgers have is property and buildings. And so in addition to working with companies like Merck and thinking about their supply chain, equally important is their footprint as far as how they operate and do the things that they do. So their headquarters is right here in Kenilworth, New Jersey. And one of the things that we're working on there is how do they reduce their energy profile and get more renewable energy into their operations. And so that's part of the bigger picture is we're working with these large corporations and getting them to understand and actually sign, which they have, Merck, a power purchase agreement that also includes renewables in their portfolio. So it's not only just about the products, it's about who they are and how they treat their employees as well.
Great, thank you. So, Robin, you talked about focusing on equity. And I'm wondering what makes this so different or novel an approach to climate change planning, and how have you been able to bring an equity lens into your work on climate change adaptation planning? And then I'll challenge Simi and Kevin to think about that as well.
I mean, I've been working on climate change impacts work. Honestly, it's 30 years at this point. And so in terms of sort of what's different about starting with equity and trying to lead off is, I think it actually really flips the way we think about the issue, because we've historically been thinking about it as a science issue. And the first thing that, even today we did a little bit of that, was the first thing you see the graphs. These are the graphs, these are the sort of the way the linear graphs are going, and this is sort of, and now, and it's sort of where, it sort of begs to me, it's like the question is, where is the opportunity for intervention? Where are the people in the graphs of sort of rising emissions, rising temperatures, sort of the doom and gloom graphs that we present to our students, and we sort of, it becomes an issue that I think for sort of, not only the average population, but sort of folks, even our students themselves, trying to make sense of where can I intervene. It's very hard to find that when you look at a line that's just an exponential curve going upward, or even just a linear curve that's just tracking into sort of 4 degrees, 5 degrees, 6 degrees of warming, and that's where there's sort of no room, and people, I think, shut down when we sort of lead with the kind of science. Not that I don't think the science is critical to understand, critical to teach, critical to sort of work with, but that's so for me, it's really putting kind of the impacts first, putting the individuals, putting the sort of what is this mean to my sort of life, and also sort of what does it mean for sort of the other things that I'm doing that aren't just that sort of science space that I'm in.
So I take a slightly different approach to thinking about equity in the context of the treaty processes. The first is that at the United Nations, all 193 members have a voice. They can all speak as equal sovereigns. They don't have equal economic power, they don't have equal military power, they don't have the same populations, but a tiny island state has the right to take the floor and express their needs and their goals in their own voice, with their own people, not represented by North Americans, but or Europeans, but on their own behalf. And that has been one of the things, it's one of the reasons that the negotiation failed in Madrid, because the industrialized countries and the countries that are at risk from climate change had strongly different views on what needed to be done. But everyone was able to talk about it. That's something. The other thing is that environmental treaties now normally contain a capacity building and technology transfer component. And I was totally thrilled when I was talking with Josh and other folks from the Glider program to learn that we actually are doing that kind of technology transfer with the gliders here at Rutgers. And actually, as I've talked with professors in a number of labs, people come from all over the world, from developing countries, and they come here and they learn the skills they need. What we need to keep doing, and we need more resources for, is to support ongoing engagement, because they go home and they can't afford chip time. They can't afford the labs to keep doing the research that they learned how to do here. So.
Yeah, and real quick, the thing that I think about as far as equity, and again, speaking about business, I'll stick within my lane, is that these large entities that actually sit sometimes in our communities are part of the community. It's no longer that I can manufacture and make things and then sell them and just care about the bottom line. We are physically, and if you think about Newark has 30 large corporate entities that sit in Newark. And for that to be the case, and for them to have the economic challenges that have happened over the course of the last few years is quite striking. So that's the reason why climate and their impact in the city itself is part of the equation. We've had discussions with what we call anchor institutions about how they, in a sense, integrate with the community, how pathways to employment, for instance, are part of that equation, diversifying their workforce, and making the folks that have to buy their nonsense look like the people that actually work there as well. And so equity and corporate social responsibility is a huge part of the discussion that we're talking about today as well.
Thank you. So I'm gonna flip it a little bit, and I didn't pre-prep you this, so I'm taking a risk here. But we are here with Rutgers Global, and I'm just wondering if there are cultures, other institutions, other countries, other places around the world that we can learn from here with respect to these issues. Anybody want to take a crack at that?
Cultures,
Places, countries, folks that come here to the United, or could come, we can learn from here.
Thinking about what we might, an ask that we might make of Rutgers Global, is this what you're asking for? Where do we want to go? Who do we want to work with?
Or who can we learn from? Are there small islands, nations, and states?
Even though we had, and I think Paul brought this up in the first group about sub-Saharan Africa, obviously there's challenges, but with the program that Global hosts, the Mandela Washington Fellowship Program, which I've been a part of for the last 5 years, even though the fellows come here from the various sub-Saharan African countries to learn more about how they can go back home and be more sustainable, the interesting thing is that I believe we learn a lot more from them because of the challenges that they have. And this last trip, several of the countries, I got them together and we went to Newark and we went to Jersey City and asked our fellows what they could contribute to the betterment of the not only the physical environment, the climate, but also the conditions of people there. And it was amazing to flip the scales, or flip the chart on it, meaning that we're going to come here and we're going to tell you that homelessness, for instance, in our countries is minimized because family and our culture wouldn't allow that to happen. And so talking with the populations in our cities about their experiences and what we could learn from them actually was an eye-opener for me.
Every time we engage with colleagues at depth, so one of the lead negotiators for one of the small island states talks about traditional knowledge. And initially, like, okay, it's the high seas, you guys, what's the relevance of traditional knowledge? But as we start unpacking it, you start learning, actually, about another dimension of the ocean and historical ocean knowledge. And I'm happy to see Josh nodding over there. So it's so that's one aspect of it. And talking with Chinese colleagues, understanding more deeply their perspective, and thinking about issues like representativeness globally. I co-authored a paper with someone in my department about geoengineering and public participation. And the question is, if you're thinking about China, what does public participation mean? So talking with colleagues from China about that as we think about how to design systems. You have to do that. You have to engage widely if you want to achieve things that involve the entire planet. We can't just think about things from our own way of organizing our government and our decision-making and our norm shaping.
Well, I mean, we're sort of right up there, like, as the highest consuming nation per person. And so I think, really what Rutgers Global can do and what that sort of piece is sort of to actually getting our students out to see what other patterns of life look like outside the United States. So seeing even just going and spending time in Western Europe and seeing, wow, people, they're using so much less. So there are many countries in Western Europe, of course, are sort of modeling, sort of the American dream is sort of, perpetuating itself all over the world. I think seeing that opportunity to actually see, like, wait, the way we do things in New Jersey, the way we do things, the way we're doing infrastructure in the United States isn't the only way we can do this. We don't have to be completely car-oriented. These sort of things that are taken for granted by my own kids who I'm raising here, and they haven't spent a huge amount of time outside the U.S., just having our students see these other models and see that other ways of being are possible.
I should add that a lot of our students here at Rutgers are first-generation Americans, or their parents are, and they bring expertise and perspectives that are terrific. It's not always easy to get it to come out, especially in a big class, but when you're in a seminar, you're hearing from students what they know. It's wonderful, and so much easier than going abroad.
So I'm going to ask you the same question that I asked the first panel, I warned you. But from your personal experience, provide an exciting moment from your work or a trend you're observing that would give you some inspiration and hope for the future.
So, I mean, I guess, one of the things that gives me probably more hope than anything is the reality that most of the changes that we've been talking about, in fact, all the changes that we've been talking about are actually fundamentally social problems. And to me, that's hopeful, because if God was causing climate change, what could we do? But we sort of have that possibility. And so that piece, married with what Josh was talking about, what Bob mentioned, and so forth in the earlier panel around the growing interest of young people, this sort of Greta Thunbergs of the world, that sort of wave of folks who are actually now just kind of starting to enter our classes, where they want to do something, they know that something needs to be done, and I think we have the opportunity to really give them the tools to do those, to sort of start to really be agents of change and agents of transformation. So all those things make me super hopeful.
In fact, Emily Cheng here is one of those students, and it's been, she's gesturing to her colleagues, but I don't know all of you. Oh, I do know some of you, yes. This table over here, they're the people we're talking about. So I was going to say something very similar. I think that we have the science, we have technology. What we need is a change in norms. We need a change in the way we see a good life, a happy life, a satisfying life. And I'm very encouraged when I think about my childhood growing up during the violent period of the civil rights movement, and seeing that the civil rights movement continues on. We've made progress, but we slip back, we go forward. And I think that's a good reminder for us that sometimes things that, it seems like, oh God, it's the end, we failed. It's not, it never is. History goes on, and if we keep pushing, we sometimes do make progress. We are in a different place.
Yeah, and I'll second the table number 4, being the shining star for the university. So just a couple things. One being that the students here at the university want Rutgers itself to be reflective of everything that we've talked about. And that's been done over the course of my time here at the university, more notably recently with Bob and others on the climate task force that's been now formed, that we now start to think about the university and the place where we house our students for 4 or more years. And what is Rutgers doing to actually be reflective of what society is doing? And so you see a tremendous push behind the scenes from the students. This is not, the faculty or the staff saying, hey, I think this is a great idea, even though we have folks like Mike Krenides and others that have been doing this for years as well. But it's really enlightening to see that the students are the ones that are saying that we need to get our house in order. And when we start to talk about the measurements that you saw across the globe, what dot on that graph represents Rutgers? What are we doing? We're great exporters of information to the world, and part of that story should be about who we are as faculty, staff, and students. And it gives you, I think, more credibility when you're actually saying that you actually have your own house in order. And the students are the ones that are actually driving that message. So that gives me a tremendous amount of hope. And then the last thing is that students are not sticking within their own silos as well. We see a lot of cross-disciplinary type work that they're doing together, knowing that the supply chain management department should be strategically partnered up with the meteorology department, because
if we can't move goods and services because of climate change, well, guess what? That's going to affect your bottom line as well. So identifying that there's more to your education other than the major that you're taking, it really does take you to understand what's happening in all the other disciplines in order for you to be a true innovator and someone that's really going to contribute to society.
Thank you. Let's thank this panel. And stay put. You've been good sports. We've been doing all the talking, and I've been doing all the questioning. So we're going to invite Paul and Josh and Joe and Bob to join our panelists, and we're going to open it up for Q&A. So.
Just disconnected.
Too enough seats. You can add it later.
You're right there in the middle, Paul.
Oh, sorry.
Okay, we only have one mic, so let's see. Let's see, Alan.
Hi, I'm Alan Roebuck from the Department of Environmental Sciences. The presentations you made have been very stimulating. I thought about a lot of things, but I just want to bring up one issue, which is carbon offsets for our travel. Whether you go to Tanzania or Portugal, as Simi told me she was just in, we travel a lot. We want our students to travel. I just came from the American Geophysical Union meeting last week in San Francisco, which is being shamed because 28,000 people go there to talk about geosciences and we have carbon emissions. I asked if I could use my grant to pay for carbon emission offsets, and I was told, no, those are donations, you can't do it, it's not allowed. But the European Geoscience Union next year is paying carbon offsets for everybody that travels to the meeting. So surely Rutgers could pay for it, and doesn't cost very much. So what can we do to get Rutgers to do that, to decide which are shams and which are real carbon offset programs, and then to subsidize and pay for all of our travel and make a statement to the world, Rutgers is concerned about these emissions and at least we want to make our travel carbon neutral. What can we do and who can we talk to about it? I don't know, Bob, are you in charge of this now as far as your committee or not?
The task force is in charge of analyzing the problem and making recommendations. And I think this is something I would certainly put in the list of topics we would want to investigate, including figuring out what the policy would be for validating that offsets are actually causing additional carbon emissions reductions and aren't simply salving somebody's conscience.
And actually, just the point about travel, our travel, we're tremendous travelers, we're tremendous emitters in terms of our travel, and so thinking about ways to reduce some of our travel or do some, Skype presentations at conferences and so forth, I think is something we're also, just in terms of sort of documenting the university's emissions, that's going to be a big piece.
And Robin, could you want to point out, we did bring in Marshall remotely.
Oh yeah, at our conference, our Green New Deal symposium last month, we had one of our speakers actually presented remotely and did a fantastic job, so I think.
And I was to say, on that, I've started declining university invitations and offering to do electronic visits instead, and the one I've done in this last semester was, in fact, probably at least as successful as spending 2 days to go and fly out to Austin and do it in person. The other thing I want to say on offsets is that I've thought about this in my own personal money because I'm willing to spend money on this. I actually decided to figure out what I would spend based on social cost of carbon, based on my emissions, and then invest that money in supporting political efforts to create an environment that will cause larger scale social change, because I think you actually get greater carbon emissions reductions by investing in political change than you do by investing in individual projects. But I don't think that's a viable solution for an entity like the university.
I was just going to say, and Robin just touched on it, but the technology is getting really quite reliable and allowing us, we're connecting classrooms. So we have classrooms in Spain connecting with ours, where now the biggest limiting factor is time zones and trying to find a time when everyone can get on a connection at the same time. When you have 6, 7, sometimes more time zones involved in a discussion. And so I think we're looking at it more as an opportunity not only to minimize our own travel, but to enable our students to virtually travel to these places and to connect with students in other places more easily. And it takes less time. You can do it in a lab period.
But sometimes you have to travel, and it's good for you.
Yes.
So Alan, how real are offsets? What is the reality of the offset?
That's the
You
question.
pay United Airlines, say $20 to offset your carbon. What do they do with the dollars?
Yeah, we have to do research on that.
Sir, I do research on that.
Good.
Tell us.
Do you want me to answer?
Yeah.
Yes.
So a lot of companies.
So identify yourself,
Sorry.
Pam Mackley from.
Pam Mackley from Ecology. A lot of companies will spend that money on tree planting initiatives. The track record on those is extremely mixed. You have to double check and see where it's being invested. I agree with Bob that I think these are basically things that make us feel better and may not be the most effective strategy. I would say teleconferencing, reducing our own travel, these are probably more effective. But if you have to do offsets, yes, we have to find places where the investment actually is.
So actually, I could speak to one thing about that, which is kind of interesting locally. So we'll talk about locally. The largest CSA in New Jersey is an organic farm, Honeybrook Organic Farm, and the farmers there come to many of our events, and they're very concerned about this. And so they're thinking about a model where they're actually going to create their own little bank. And so the members of their CSA will be able to buy offsets.
What's the CSA?
Community Supported Agriculture, where you go and you are a shareholder. Well, Alan, come join. You are a shareholder, and you go and you get your produce there every week as a shareholder in the farm. And so they're going to set up a bank, and you can purchase offsets. They're going to have somebody who's going to calculate it for them, and then they want to put the money back into using biochar on their farm and planting trees and doing other things that will make them a carbon sink. So it's an interesting model, and they're starting, and they think they can get some other farmers in the state to do that. And I think Bob Goodman had a response also.
So the Kinzells, who own and operate Honeybrook Garden, actually she's a grad of Rutgers. I wanted to change the subject after the comment. So Bob alluded to this fairly clearly, and Simi talked a bit about it, and Paul did too. I just want to reemphasize and reiterate the significance of the governance question. Of any university that I know, this one is beautifully situated to be a leader in thinking about global governance issues, not just around climate, but around all the other issues that go beyond sovereign boundaries. One of the panelists said, and it's true, that we're stuck, Paul, I think, that we're stuck with leapfrogging technologies in some areas and 19th century technologies in other areas. We're also stuck with 18th century ideas about sovereignty. And that is, in my view, directly in the way of and the challenge for solving the governance issue, because all of these issues that we're talking about go beyond sovereign boundaries. They're shared. There are people in one sovereign area who cause difficulties and troubles for other people in other sovereign communities, and we've got to figure this out. And so the discussion has started, and it's astonishing to me that before now we haven't addressed this in an institutional way, and we're just beginning to do so, in my view, in a meaningful way. And I really think we need to advance that as a major priority for the institution.
So does anybody want to respond to that? Excellent job. Well, we could be in the Olympics here.
The sovereignty issue is a complex one. I alluded to it a minute ago as actually a means of providing representativeness in the global world, but this is sort of down in the weeds in what international lawyers write about in our scholarly work, is the notion that we are doing transnational law, not international law. So international law is between governments. Transnational law is the contracts between your companies that you work with in that global supply chain. It's the civil society organizations. It's the other students all over the world that Table 4 is communicating with. It is a much broader phenomenon, and it's important that we're aware of it and that we work with it. The other thing, I had another thought about it, but I may just throw in later in the conversation because it's escaped me at the moment.
Okay, anybody else want to respond to that?
Well,
Bob.
So Bob, there's one good example of that is the Montreal Protocol. Okay, so this was an example where the ozone hole was thought to be a threat globally, and all the major companies that produce hydrochlorofluorocarbons, DuPont, Solvay, many of them, they all got together and they went back to redesigning their chlorofluorocarbons, all of which, by the way, were off patent. All of which were off patent. So they had to redesign their plants and make a half a penny per boom, and they did. So that's been, I think, a successful view. If we had magic bullets for the energy system now, and we didn't have a global investment in the infrastructure and the extraction processes of fossil fuels, I think we could do something. But the economics of that are so deeply enrooted in so few countries that it is very difficult to figure out how to get out of that. I'll give you an example today, which is the boundary condition, which is phenomenal to me. So right now, Australia is having the hottest world records. It's 50 degrees in parts of Australia, and it's one of the major exporters of coal. I mean, it's phenomenal to me. So the paradox is, we can do something in some cases, but in other cases, it seems like the economics just don't allow it. So it's an economic issue, not just a global governance issue.
It's a social issue, not just an economic issue, because what we do with our economics is a choice. And it comes from our norms, our sense of responsibility. There's a study that shows that pulp mill owners, pulp manufacture is a very dirty process. And when they live in the town, they over-comply with pollution laws. And when they're remote, they don't. So it's a choice.
So I agree that Montreal Protocol is a great example of a successful international environmental treaty, and in fact is probably also the example of the most successful international climate treaty, because the gases controlled in the Montreal Protocol are extremely strong greenhouse gases, and their emissions have been successfully reduced. But it's also, for reasons that Paul alluded to, a much simpler problem with very few key actors, right? There are few companies that if you brought them on board, which they did, they would change the political dynamics. The global climate crisis and global ecological crisis are extremely polycentric. Right? So we have, we're talking about something that is pervasive through the economic system of the world. So it's a much more complicated and I think much more interesting academically, but also much more challenging problem to deal with. And so, as I think alluded to earlier, I think that we're talking about transnational political movements that we're taking. We're getting the democratic crisis is a global democratic crisis. It's not constrained within national boundaries. But we also see things like the climate strike movement, which is transnational. We're also seeing cities around the world act together. So it's a very polycentric problem. I think it will be very challenging and important to figure out how to make that work, and I think it requires lots of different levels of intervention and analysis.
Well, that's exactly my point.
Yeah.
Exactly my point.
Anybody else want to take this on?
Okay, we would like to get some students to ask some questions.
Hi, I'm Kai Wen. I'm a PhD candidate at Rutgers, of course, in geography. I look at climate change adaptation. I think one thing that I've been thinking about is the lack of youth representation in decision making. It's often based on hierarchy. And so, you know, we talk about it's the social issues, political issues, it's the governance issues. It's also an intergenerational justice issues. Bob said that the decision we made today about our own vulnerability is going to affect future vulnerability. And so I was just wondering, what are your thoughts on really creating pathways for young people, you know, people who haven't gotten the chance to gain the expertise to talk about these issues, but climate change is the issues that concerns them and about their future, you know. So I think, what are the ways in which we can include more the voice of, you know, people who are going to be affected and would like to have a decent chance of having a nice planet to live in the next 30 years. So.
So I have a question for you. One of the solutions, or two of the solutions that have been proposed in climate change are removing the garbage from the air, CO2 extraction, or spreading some kind of particles into the stratosphere to reflect sunlight back to space. You discuss that in your climate research programs? So is climate engineering a topic that is in the geography department? Is it in, Alan, do you teach this?
Oh yeah, I teach it in all my classes.
Okay, so do you interact with these guys?
No, they didn't invite me.
So there's a stovepipe in a way. So this is a huge problem in this university. It's a huge problem in this university, is the stovepiping. And I think that at some point, because I guess geography is an SAS, is that correct? And you're in SEBS, that we need to overcome these barriers and make this university a university, not a consortium of schools. And that would, I think, address at least a first order the issues of the education of you, so that you can be a much more informed person when you step out in your PhD and go into society and try to affect the change that you're looking to affect.
Yeah, I don't know if that answers your question about wanting to have voice, but it certainly responds to the one thing I thought, gee, if I get to have an ask today, that's my ask. It's to have some reorganization so that it's possible for Alan and me to teach a course together and have that credited to our departments in a way that we can justify doing it. We want to do interdisciplinary teaching, but it's very, very hard under the current system. There is an under the UN, youth is a coalition group that you can participate in. You don't have as much power as if you're the head of a government, though.
Yeah, and just real quickly before I pass it down to the very end. Also, as part of that is the governance of institutions and having students as part of that. Now, obviously, we have the student governance and university senates and others, but that coupled with what was just said has to go hand in hand, because I think that that's the reason why we're here, is because of our research and our students as well. But getting involved in the decision making part of what we do as an institution is something that is critical. And I know that back in the day when the Students for Environmental Awareness were just getting formed 30 some years ago over on Cook College at the time, they were really good at getting into the ground and actually getting involved with the administration and the decision-making processes. And so they were able to get different types of teaching done. The interesting thing is that there's 70-some thousand of you, and if you all got together and actually said, we want X, whatever X might be, I'm pretty confident that it'll actually get done. The problem is then how do you organize 70-some thousand of you to be together on a particular thing? And when it's done effectively, and decisions are made, and changes are made. So really start to think about not only the teachings that we have, but also what can you do collectively as a body of very important people here at this institution to reflect change.
I would say, no one's going to give you power, but your generation is actually now the biggest generation, and so you do have that power. There's more of you than there are boomers, certainly a lot more than the Gen X folks in terms of the millennials. So it's right there. There's an election coming up, and it's here. You guys have it. Just take it.
Yeah, I was basically going to say what Robin says. If we're in New Jersey, so we may not be a swing vote in the presidential election, but you can go and spend your time on working on campaigns. You can be active in congressional elections. If young people, millennials and our undergraduates are not millennials, they're Gen Z, but millennials.
Technically a millennial.
Oh, yeah, I'm technically a millennial. Yeah, very. But in millennial, if people under 40 turned out to vote in the same proportion as people over 65, we would have very different politics in this country.
And I guess I'll just remind you that Pennsylvania is not that far dry if you want to work on it.
I was going to take it a slightly different way and say that I think one of the things that has impressed me in my time here at Rutgers has been the opportunity for students to get involved in research outside of the classroom, right? And the lectures that you go to and the courses and the discussion here already about the team teaching that can happen with different courses is really important, but also you are at a premier research institution, and there are interesting questions that we've all talked about that students are involved in, not even just at the graduate level, but at the undergraduate level. And as a graduate student, you can mentor undergraduates that are getting involved in these research. And so I think we've seen great support from the administration on these opportunities for students to get involved in the research. And I would say just grab it and take it and work with different faculty groups, different labs that are doing the research. There's a lot of relevant questions that you can make a contribution to right now. You don't have to wait until you have a degree next to your name. You can do it now.
I'll just be really, really quick. Just to say, this kind of ties into a thank you for inviting me to be part of this group. I was flattered to be asked because look at the panel of folks that I'm here with. And I just graduated graduate school 4 years ago now. And I'm on a panel with Paul Palkowski. Like, how does that happen? But one of my point in bringing this up is I think there's a challenge. This is a challenge for the university structure in that we need to make sure that the students have a voice on things like this. When I was in graduate school, they did a search committee for the new university president, not here at Rutgers, this is a different university. There was not a single graduate student on that search committee. And there was one undergraduate. And this is the students are supposed to be what the university is about. And Rutgers is better at this than my graduate university was. But the point is it's a challenge for all of us too, to make sure that you're in the room on these committees, you're part of the discussion. And so I challenge all of us to make sure that we follow through on that. So I'll end with that.
So I think we have time for one more question. Lily. You can get the last question.
Thank you. I just want to look back in history a little and remind people with regard to cross-unit teaching that when Paul founded the REI, 12, 13 years ago, something like that, one of the things that he insisted upon was a course. And he insisted upon it. And so eventually a course was created, and it was energy and climate. And it was a signature course that was based in SAS. But it involved SAS faculty, SEBS faculty, Blaustein faculty, and we didn't talk about who gets credit for it. We did it because we wanted to do it. So if you want to do it, just do it. You know, this is the beauty of Rutgers. Rutgers is a place where you do it, okay, and then you figure out what you have to do to sort of fix it later. So I would encourage. Oh, and by the way, I'm sorry. 2 years ago, the course was canceled because there was a lack of interest. We started out, the first class we taught had 300 people. registered for it. The last class we taught had 90-something, something like that. So it's possible to do, it's important. There is an interest, I mean, the students really do want that, so I would urge that this be thought about again in all ways that you can.
Well, did anybody want to respond to that? We're good? Oh, Paul, you do.
Yeah.
Surprise.
Well, I mean, thank you, Lily, but we've changed the budgeting model of the university. And when I put that course together, I had to put 4 deans into a room at that time under the all funds budgeting, close the door, lock it, and basically say, we're not going to leave until we figure out how we can do this. And we all agreed that that had to be done, and it was done. Today, I think it's a little more difficult. But having said that, I think we have to go beyond the dean level here. This university has to function as a complete university. A PhD student should not be a PhD student in geography. You should get your degree from Rutgers University, and you should be taking courses in economics if you want. You should be taking courses in climate if you want. You should be taking courses in the business school if you want, and they should all be credited towards your degree. We should not be siloing any student in this university. Any student, undergraduate, graduate student, doesn't matter. That is really the problem we have as a culture of the university now that we have to break, and hopefully with the next university president and the next governing body of this university, we can understand how to change that. Because if we don't do that, we're just going to be siloed and siloed and siloed for the next generation.
We have one student who would like to ask a question, and I think we will indulge you.
Hi, I'm Michelle Wong. I'm a senior here studying supply chain and political science. And my question is, so there have been a lot of reference on our table and our generation for taking the reins and driving the conversation in climate change and policy and everything related. But how do the people, how do you panelists and the rest of the room make sure that this message is also, what is your responsibility in doing that as well? We can talk about how New Jersey is more liberal and we accept this research and these values, but the rest of America and the rest of the world does not necessarily hold those views, and I don't think it's up to just the students to change their point of view, especially given the years of research and work that you've done on this. And so how do you try to touch every aspect of society and convince them of this message?
I'm letting Bob go first this time.
Go ahead. I think I agree. And I think this is actually something where Rutgers does quite well. The climate area, the energy area have, the faculty in this area are constantly among, the 50 people most involved and the most cited in the media. A lot of us spend a lot of time working with policymakers. Robin has taken a leadership role in the New York City panel on climate change for many years. And I think it's really important to do. I think as with all universities, it's something where we can think and make sure the incentives are aligned, particularly for faculty earlier in their career to do it. Once you're tenured, you can go and do whatever you want. And I think a lot of people working in this space actually do view being engaged very, very publicly. Work like Marjorie and Kaplan and Jean Herb and Lisa Almuller have been doing to work with communities on the ground in New Jersey, I think is also really important. That's what we're trying to train graduate students in the Coastal Climate Risk and Resilience Program, which is an interdisciplinary graduate program, to do. Is a model of that, and I think we actually have probably some of the best examples of doing that at Rutgers compared to other universities, but it's something that I think we should be investing more in.
So I'll give you an example of a Rutgers graduate that has changed the way that we operate in energy. Heather Zickel was a graduate of Cook College years ago in environmental sciences. Human ecology, sorry. So Heather went on to become one of the campaign not leaders, but a campaign advisor to a senator from Illinois at the time, young senator from Illinois, who went on to be the President of the United States. And when Obama was elected, she went into an office of energy research, not research, it was energy management at the time. And she designed the CAFE standards for the automobile industry, which we're living with today. So here's an example of somebody that has been, in a sense, transformative beyond the scenes from this university. And I just encourage you to think about alternative pathways. Go and become, if you can, working in the government. Work with NGOs. Work with these great companies like Merck or Johnson & Johnson. Try to think of pathways where you can make a difference. And another way to think about it is, and unfortunately we don't encourage this that much in university, become a teacher. I mean, think about it. The most transformative person probably in your life, aside from your parents, was your kindergarten teacher or your first grade teacher. We don't encourage that. And just think about ways that you can make a difference to society. Thank you.
And I would say we're all, many of us in this room are teachers, and we have that opportunity to be that transformative. For me, my most transformative teachers were the ones that I had actually as an undergraduate at the University of Wisconsin. And I think, so making that difference, what we're trying to do is not just saying, go do it, guys. We're trying to give you the tools, and above and beyond the sort of social kind of outreach work that we're doing, the community work, the work with cities and governments. I think that's sort of what we're here for.
So,
And just picking up on what Robin said, it's critically important that the university sees itself in the surrounding communities as well. You know, we are at this table here, we probably could solve the world's problems in about 30 minutes. But you step right off campus and there are folks that are in desperate need of the types of information that we're talking about. You know, there's social and economic issues that are happening right in our communities. And then we just sort of like bypass them to get to our office sometimes every day. But it's critically important that what we do is represented in the surrounding communities, and bringing our students as well as our faculty and staff and spending time in these communities, faith-based organizations and others, and bringing them into this discussion is critically important. You'll see the multiplier of all the things that we're talking about once the society is part of what we're doing as well.
so,
And just as a follow-up,
oh,
sorry.
it's okay.
So you talked about university, government, and large corporations, but I would like to also highlight that this is part of an elite class of where we live. And so what I really meant was the teachers, like becoming a teacher and trying to touch those people that don't necessarily get to college or don't necessarily make it to Merck or J&J, or make it into government.
I think we all accept invitations when we get them or sometimes seek them out to speak to church groups, to speak to community groups, to go to schools. And, you guys can do that too. I think we all think that that's an important part of our job, to not just speak to academic elites or government elites. The other thing I'd say is I think we seem to have a heavy bias towards both environment and international here. And it's important to go to talk to people in your outside of your discipline too. I mean, you're getting a PhD, you are part of the elite now. Talk to the other people in the elite, other elites as well. I just spent a week with a bunch of Marxists and it was very enlightening. I learned a lot.
I'll also mention the Humanity Actions Lab. If you don't know about it, you should know about it, where it is a collaboration out of Rutgers Newark, and that we're bringing Climates of Inequality here to New Brunswick next year, the year after, 2021. But that group in New Brunswick, in Newark, actually is a consortium of universities where they work with frontline communities and around a social issue or an environmental issue, and develop interactive opportunities. So I think you should look at them because Rutgers really is doing more than meets the eye. There was one more question, and I lied when I said I had the last question, but I'm going to indulge Pam because she came in today and she's supposed to be on sabbatical.
It's not so much a question as a statement, which is this is an event sponsored by Rutgers Global. We've talked about how this is a global problem.
We obviously want our faculty to have more international influence, and I have to say, this university needs to do more to make it able for faculty to do that. There are constant roadblocks for faculty who want to do research abroad, spend money abroad, hire research assistants abroad. This university does not make it easy for us to have global influence. And maybe that's something that the global office can do, but I was hoping to hear more about that because if we want to tackle global climate change and if we want to influence other governments and our faculty are overseas and have that opportunity, help us do that. Help us do that. And we're not at that point yet, and we need to do more.
Thank you. Well, thank you, this amazing panel.